So hello all PUC students, I'm Professor Diggewadi. So from Gupta Institution of Technology, so Department of Mathematics. So one more video I'm giving on that is some different formulas. One is integration by parts. The first formula which is written here, this is familiar to you. You are using almost all classes in regular. Okay. The second one, what it is there, the same left hand side, what it is there, but right hand side, there is no integration sign. So this formula, what commonly will say that generalized rule of integration by parts. Whenever that is question is about when I should use it this one, when I should use it this one. Inside integration, suppose if it is their inverse trigonometric function or logarithm function, if it is present along with that, so whatever maybe it is given to you common compulsory, we have to use it at this one. But there are some examples are there. Algebraic into exponential, algebraic into trigonometric function. I used those trigonometric functions only two, that is sine and cosine. When these two terms are there, then we don't go by that is this method, only one line single term what it is there. Okay, so u is nothing but the differential part you have kept as it is, and here you are written v. Integration of the second part itself is that is v notation. Once if these two terms, one will be present, one is after the integration, you will get it. Once if you are written, so that is these two terms, then don't check it this term. Yeah, irrespective of sign of these two terms, the series is goes to alternately positive and negative. Okay, and here you are written u dash double dash triple dash, means here you will get it successive differential coefficient of the differential part, and v1 v2 v3 and so on. So that is integration, again you have to successively integrate it. V integration is v1, v1 integration is v2, v2 integration is v3. This process is continuously goes. Question comes where it will ends. Okay, very simple term. Which term is differentiating, that term successively differentiate until you will get it the constant term. And irrespective of sign of both the terms will be having series is alternately positive and negative. Here the first term is x square, algebraic into exponential or algebraic into trigonometric function. So commonly these two terms are there, so we can write it the answer directly. So algebraic term as it is, what is the integral of this term? So that much I have written as a second bracket. It may be positive, negative. Try to keep both the terms in bracket only. Okay. Now, irrespective of the sign, negative sign, positive, negative, positive, negative. Differentiated the first open bracket, that is 2x. Its integration, only numerator integration, what you will get it, e raised to 3x divided by one more 3. That 3 and already existing 3 is 3 square. So it means what a, what it is there, its power will be goes on increasing. So what the power is there, that's gives to us as how many times you are integrated. Okay. Now here if you have taken, this is already once you are integrated, means what this is the actually second time, but from this is considered as a single term. First time differentiation, again you differentiate, you will get it 2. So one more time you integrate it, that is 3. Okay, so constant term you have reached. Next term if you are written minus sign, differentiation of 2 is goes to 0, but integration will get it 0 into anything is goes to 0. Therefore algebraic term, what it is there, successively you have to differentiate until you will get it constant. Either algebraic into exponential is there, or so algebraic into trigonometric function is given to you. Just you have to see that. Okay, here x cube as it is, integration of cos ax is sin ax by a. Okay, once you are already integrated, okay, this is called v. Now start it to differentiate it. Positive, negative, compulsory it is there. X cube differentiation is 3x square. Again you integrated this term, minus 2x cos 2x divided by 2. 2 into 2 is 2 square. Now differentiation of this term is 6x. I have written here. Its integration is sin 2x divided by 2. That minus sign remains as it is. 2 square is converted into 2 cube. Its differentiation is 6. And again differentiate integration of sine is goes to minus cos, that minus and this minus is plus. So here I written that, so that is the term. Okay, now every time don't expect it directly, they can give it to you. Sometimes the example may be given like this type. Okay, so both are the same. This example can be done solved by using substitution method. So substitution is root x is equal to anything you can take it other than x. I have taken that t. So and x squaring on both sides. X is goes to t square. We have needed root x equal to t. I have got, okay, this is also t. But what is dx? You will get it differentiation. You will get it 2t into, that is dt. Okay, 2 I have written common, again algebraic into exponential. Here I have not kept the bracket because of e raised to t. Once you differentiate or 100, sorry, once you integrate or 100 times you integrate, it remains as it is. So no change in the constant, nothing. Therefore, I have kept as it is. Okay, so it means what, that is goes to when I should use the integration by parts. That much I try to understand. Generalized rule I am giving. One is algebraic into exponential, second one is goes to algebraic into trigonometric, or sometimes after the substitution you will get it algebraic into so exponential, like this type. Okay, now yeah, that is, yeah, previous one case, one example substitution, then integration by parts you are taken. Here most of the examples we are solving substitution only. Okay, so now here you can see that this is given to you. So very easy. Sin square x is there here, 2 times cos square x is there. But one thing you have studied, sin square theta plus cos square theta is 1. Means what, 2 you write it 1 cos square x plus of 1 more cos square x. So here it is comes 1 plus of cos square x. So simplification also I have done in this place. Okay, and numerator what it is there, sin 2 theta formula, 2 sin theta cos theta. Now this answer can be written, two different answers are there. So both I have given in this place. So it is depending on which answer is printed. Okay, so just you have to see that. Somebody will think it, I want to substitute cos square x is equal to t. Okay, they will write it as, actually you will get it minus sign in this place. So cos square x differentiation is minus 2 times cos x into sin x dx. But that minus sign I have written directly in this place. Okay, so this is minus sign I have kept as it is. This is gives us as 1 upon 1 plus t square. 1 upon 1 plus x square is tan inverse of x, and that t itself is called cos square x. Suppose if answers are in terms of tan inverse, it is okay. Suppose if the answers are not in tan inverse, so you have to see that what is the possibilities there. That is called log. Okay, while substituting 1 plus cos, only cos square x is equal to t, you take it directly 1 plus cos square x is equal to t. Okay, then what I have did, this is minus outside, because of when you take it that is t, you'll be having minus sign. Okay, and here it was not there, earlier it was not there. I multiplied and outside also multiplied. It's a differentiation of this term itself is numerator, f dash of x divided by f of x. So this minus sign remains as it is, log of the denominator. Okay, means what, one of the formula which was given in earlier video, f dash of x divided by f of x, it is used. Okay, this is one slight different example. So this is given as root x, this is x 1 plus x. So I cannot apply resolving into partial fraction because of root is there, irrational power is there. So it means what, we cannot do it integration by parts. Then what you have to do, substitution. What the substitution is made, 1 plus of, that is any term formula is present or not, you have to see that. 1 plus tan square theta is secant square theta, 1 plus cot square theta is cosec square theta. Means what, there are two options are there. Somebody will substitute it, x is equal to tan square theta, 1 plus tan square theta is secant square theta, and you will differentiate it. Okay, suppose if the answers are in terms of tan, put x is equal to, that is tan square theta. Suppose if it is answer is in terms of cot, so you can take it as, so that is cot substitution. Okay, otherwise you are taken in PUC tan inverse of x is equal to cot inverse of 1 by x or something. Okay, so like that type, that is goes to, it can be adjusted. What I have did, so in this example, uh, so put that is tan square theta. Okay, so if you are needed, just a moment, I'll solve it. So just so, yeah, here you see that example was there, that is root x divided by x into 1 plus of x into dx. Direct substitution is put x is equal to tan square theta. Okay, dx is 2 tan theta. Differentiation of the tan theta is secant square theta into d theta. So directly you can substitute. This is okay. X is tan square theta is nothing but root x is only tan theta. Okay, here you will get it tan square theta. 1 plus tan square theta is directly you write it secant square theta. So this is 2 tan theta secant square theta d theta. These two terms cancels. Okay, tan 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 square, here square is there, so all together is 2 outside. Okay, into theta plus of integration constant c. This is 2 as it is, theta is nothing but in this place. Okay, so yeah, in this place root x is equal to tan theta. So therefore theta is goes to tan inverse of root x, tan inverse of root x plus of c. So out of that is these examples, which example is having, so that answer you have to check it. Answer is yeah, there is no example is having two notation, only one answer is there having two notation, 2 times tan inverse of root x. Okay, so now next one you can see that, yeah, this is very interesting example. Yeah, if you have integral of some function is equal to new function, it is everyone is known, then asked question is this type. Okay, what you have to do, integration and differentiation both are converse to each other, therefore I'll write it as g dash of x is equal to f of x. Means what, according to the given data only f of x is equals to g dash of x. This term can be written in terms of g dash of x, places interchange g of x into g dash of x. At beginning only I was given f of x raised to n into f dash of x. F of x raised to n plus 1 divided by n plus 1. Okay, so g of x into g dash of x comes g of x raised to 1 plus 1 is 2 divided by 1 plus 1 is 2. Therefore, this is the answer. So most probably I have given in this place. Okay, so so we cannot cover the entire thing what it is you have studied in the PUC, but what the best in general integration, what it is there. So that much I'm giving to you. And one more is in generally up to here what the observation we have made. Application one example comes, that is for 1 marks. Okay, so in generally you have taken that, that is commonly area between the two curves, area between one curve, one line, that is called two equations you are given, y equal to f1 of x, y equal to g, that is f2 of x, like that type. Application part what it is there, so try to remember, because some standard examples are there, those answers also if possible try to remember. Okay, don't solve, go on solve it in the example continuously in the exam hall. So only within 130 seconds or maximum of 1 minute, if you are able to solve, then only you practice, that is goes to, otherwise you only guess that is the correct answer. So which formula should be used, and everything should be calculated in mind. Okay, so that is forthcoming 29, 30, 31st August, what the CET examinations are there. Everybody try to write neatly, and best of luck for your forthcoming examination.